This video is about measures of spread, and we're using the same examples as last time. So we're back to our 9 employees and their annual salaries, and this time we're going to work out the range, the interquartile range and the standard deviation. So we know that the range is highest minus lowest, so that is 75,650 take away 38,200, which is equal to 37,450. Okay, now the range is not a very good measure of spread because it's subject to odd variations. And for instance, an odd variation here could be somebody who just works part-time, or somebody who worked for part of the year and then left, or whatever. But they're not typical of the group. But the highest and lowest values are very prone to odd values. So to improve that reliability of range, we come in to the interquartile range, which is actually the range of the middle 50%. So the interquartile range is the third quartile minus the first quartile. So we have to work out what the value is that's 1/4 of the way through and 3/4 of the way through. Just to relate back to something that you already know, the median is halfway through. So the quartile is sort of like half again, if you like. So the quartile, the first quartile, is found at n+1 on 4. Now we've got nine numbers here, so that's 9 plus 1 is 10 over 4, and that's 2.5 or 2.5. So the 2.5 value is going to be the low quartile. So this is 1, 2, 3 value, so second, third. So the 2.5 value is halfway between those two, and because they're the same, halfway between must be 44,500. The third quartile is going to be 3 lots of n+1 over 4, and that turns out to be 7.5, because it's 3 lots of 2.5. And if we go through 1, 2, 3, 4, 5, 6, this is the 7th value and this is the 8th value. So the 7.5 value must be halfway between those two. And if you go halfway between those two, you will get at approximately, or exactly, 53,125. I'm taking a few shortcuts here. So the interquartile range is 8,625. Okay, that is the range for the middle 50%. And the standard deviation, and we'll once again, to do the standard deviation, you need to make an assumption about whether it's a population or a sample. Let's call it a sample. And when you do that on your calculator, you'll just get 10,674. I can't demonstrate the use of a calculator with this kind of video. Moving on to the next one, we've got our number of people per household and that sort of thing. So we'll do the cumulative frequency again. So transfer the first one over as 9. 9 plus 11 is 20, 26, 32, 36, 38 and 40. That's good because they're the same. And we know that the range here is highest minus lowest. 7's the highest, 1's the lowest, which is 6. Okay, because if those numbers were in a line, the first number would be a 1, and there'd be 9 of them altogether, followed by 11 2s, 6 3s, and then on the end there would be 7, 7, 2 7s in other words. Now the interquartile range is the same as before, it's Q3 minus Q1. Now, this time there's 40 numbers, so the position for Q1 is going to be 40 plus 1 divided by 4, which is 41 divided by 4, which is 10 1/4, or 10.25. So would be after the 10th 1/4 number. Now, we know that the first 9 numbers were 1s, so the 10th number through to the 20th number were all 2s. Now, for this here to be the 10th 1/4 number, we need to know about the 10th and we need to know about the 11th number. And both the 10th and the 11th numbers are 2s, because you see this second line of the table, the cumulative frequency of 20, well, 1 more than 9 is 10, so the 10th through to the 20th scores were all 2s, so the 10th and the 11th scores were 2, so the lower quartiles are 2. Now, likewise, the upper quartile is going to be 3 lots of n plus 1 on 2. So it's going to be 3 lots of n plus 1 on 2. Sorry, where did 2 come from? 4 quartiles, so you divide by 4. So that's going to be 3 lots of 41 on 4, which is going to be the 30th and 3/4 score. So we need to know about the 30th score and the 31st score. Now, if we have a look coming through this cumulative frequency, there's a 32 here, and 1 more than 26 is 27. So the 27th through to the 32nd score were all 4s. So that means that the 30th score and the 31st score were 4s. So that means that the third quartile is a 4. And 4 minus 2 is 2. And this time the standard deviation, treating it as a sample, will be about 1.75 if you go to 2 decimal places. All right. Okay, in this question, we've taken the data on superannuation returns and we're using the stem and leaf version to answer these questions. I think it's all that we really need to do. So let's get started with it. We're after the range and the interquartile range. So the range is, as you know, the highest minus lowest, which is, the highest is 12.2. We can just read that off, and we can read the lowest at 7.0, which is 5.2. Now, the interquartile range, we know, is the third quartile, or 3/4 of the way through, subtract the first quartile, which is 1/4 of the way through. Now, we have 32 numbers here. So if we go through with this, the first quartile, so Q1, is found at the nth plus 1 on 4 position, which is 32 plus 1, which is 33, 33 on 4, which is the 8th 1/4 position. So we need to know the 8th score and the 9th score. And the quartile, the lower quartile, will be 1/4 of the way between them. So just counting, 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8th, this is the 9th. So the 8th score is 8.7 and the 9th score is 8.9. Now, if we were going halfway between them, it would be 8.8. But if we're going to go 1/4 of the way through, it would be 8.75. So we'll do that by just, I guess, just observation, looking at the numbers. Now Q3, on the other hand, is three lots of n plus 1 on 4, so it's 3 lots of 8 1/4, which is 3/8 are 24, so it's the 24th and 3/4 value. So we need the 24th value and we need the 25th value, and we need to go 3/4 of the way between them. So we were up to the 9th value before, so let's keep counting. 10th, 11th, 12th, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 and 25. So this value is 10.3 and this one is 10.5. So basically we have to start with 10.3, the 24th value, and go 3/4 of the way. Halfway would be 10.4, so 3/4 of the way would be 10.45. So by the time we do that subtraction, we will get 1.7. So the interquartile range is 1.7.